So good day guys, welcome to today's lesson. In today's lesson we are going to be changing this from the ductility class from DC low to DC high, and we'll see the effect on it. Okay, so highlight this whole structure, come back here, view revise preference, and let's change this to ductility high. Okay, so click OK. So now the concrete wall design results are available. The action will delete them, so because we've changed the parameter, the preferences. So from there I'll rerun the analysis again and we'll see the effect of it. So the analysis is done. Now let's select this, right click on it, so open it. Okay, now first of all, what you will notice is that with this we have a boundary element check, which I've explained to you. So let's go back there. I've explained previously this part in the previous videos. So what we are getting, we just need still nominal reinforcement for the one at the top, then the shear. Now for the boundary element, all it's telling you is that we have the top left, top right. So for example, let me open paint again. So this is the plan, right? Then this is the elevation. Let me just pick a typical story, the elevation. Okay, so this is the top, this is the bottom. Now we have top left, top right, bottom left, bottom right. So you can see top left, top right, bottom left, bottom right. So for the ID leg 1, so we have the edge. Now the reason why the edge is 0 is because we don't require a boundary element. What it means is that this is the normalized stress. It must not go greater than 0.15, the ratio of it. So it is in Euro code 8. You will see this ratio there. Now, so the current stress we have, maximum we have, is at the bottom left and bottom right, which is 0.013. So it's far less than this, so we don't require boundary. So let's go down to somewhere I believe we might require a boundary. Maybe this. Let's select this. Now you can see this as filled. So you can see it, axial compressive capacity for concrete exceeded. So let's go to the boundary and let's see it. So you can see it's telling you that the normalized stress has been exceeded. So this has been exceeded. So you can see the boundary edge now. So what the boundary edge means is that I told you this is the tension zone. Let's say tension zone. This is the compression zone, and this is the flexure zone. So what we need to do is to create a tension column like this. We take this, get a tension column, take this, get a compressive column. Then this point can just be nominal reinforcement, it doesn't matter. So it is in between two boundaries. So I would advise you to design with compression, because the earthquake or the wind can come like this will be in tension, and tomorrow it can come like this and this will be in tension. So we all know stresses are reversible, so that is why we always have, for example, if you have stress which is P over A plus or minus M over Z, so we know it is reversible. So when it's plus positive, it is compression. When it's negative, it is tension. So that's what we have. Okay, so we can see that. Now what we need to do in this case is that we can design it with simplified C and T. So it will just give us the compression, because now what I need to do is to design this manually. I know that I have my length as 1.076 meter from my top left, top right, then bottom left, bottom right. So I can just use the worst case scenario for all of them and to make it easy for me. But to make this design easy, I will just tell ETABS to use simplify C and T. So I can come here, right click on it and overwrite. So if you want to overwrite on a shear wall, you just come here, you can see this value here, overwrite. Then I'll change it from uniform reinforcing to simplified C and T, set any parameters I want to set here and click OK. So let's open it. Let me make it 200 so we can see very well. Okay, so all these parameters are there. Now you can see the first thing is flexure design NED and this for tension reinforcing. So you can see my tension, I require 0 rebar of this, but for my compression I require very huge reinforcements. So you can see this. So that is the effect of the boundary condition. Because it's greater than this, so I need to design it like a column. So I'll be having a lot of stirrups at that point. Okay, so I have my this is the reinforcement I need there. Then for my shear, I have almost 0. That's what it is telling me, that my shear, I'm not really experiencing shear. But when it gives you a value of 0, I will advise that you put the nominal reinforcement for the shear there. So that means at each level I'm going to have something like this. I have this, I have this, then I'm going to have the nominal shear here for this. So this one can be maybe 10 at 200 down, this will be 10 at 200, and this one can just be 10 at 300 or even 8 at 300. This is just nominal, because look at the calculation sheets. We have tension, no reinforcement; compression, no reinforcement, quite a large sum of reinforcement. So that is just it. Okay, so you can see this is what we have. Okay, so this is for boundary. This is the boundary I've been explaining about. So if you have any question, you can always drop it in the comment section. Okay, thank you very much.